You're reading for reading selection, 2 articles. So if you want to read along on the screen, that is an option. Or if you want to pull out a text, if you're in class or if you're at home and you want to pull out a text, you can go to the backups folder and all of the handouts are in the folder that correlates with this assignment. So you can go to the 4.1 folder and all of the handouts for this are going to be in that folder. All right, so just read along, put your headphones in if you've got them, and let's go. So, skydiving is a sport that many people enjoy, but it takes courage. When skydivers leap from planes, you might think that the constant pull of gravity would make them fall faster and faster until their parachutes opened and allowed them to glide safely back to the earth. But that's not quite what happens. At the beginning of the skydive, a skydiver's fall does speed up or accelerate, and it does this rapidly or quickly. But as the diver falls, the acceleration continually decreases until the skydiver stops speeding up. The diver then falls at a constant velocity at which an object is traveling in a single direction. So that's going to be a new vocab term here. So this note in your science notebook. This is a new term, and you're going to see this again quite frequently. So velocity is a speed at which an object is traveling and it has a direction. So speed is a numerical value telling you how fast you're going, but velocity adds a direction to it. So that's hence the new term. So in the case of the skydiver, that's down, which is the direction. The constant velocity reaches is called terminal velocity. This is another important thing that you need to make note of. This is the fastest speed that you can reach, terminal velocity. Usually takes the skydiver around 10 seconds to reach terminal velocity. So if you want to look at the picture there at the bottom, it shows a picture of a skydiver leaping from a plane there. So in theory, it should take them about 10 seconds to reach terminal velocity, which is the fastest that you can fall. Slide. We are looking at a free body diagram of a skydiver falling. So it's showing the forces that are acting on the skydiver. So in this, the skydiver is falling straight down. You've got two forces acting on them. You have the force of air resistance, that's this, highlighting it yellow there. And then in blue, you have the force of gravity, which is pulling down. So those are opposing forces at this point. So terminal velocity is a result of the interaction of two forces, gravity and air friction or air resistance. So this is why when you reach a specific speed, that's called terminal velocity. You can't go any faster because you have a certain amount of air resistance and gravity. And gravity on the planet's not going to change. So the only way you could go faster than terminal velocity is if you had a way to make air resistance smaller or to increase gravity. All right, so let's start reading here. Forces on skydivers. Skydivers that make them eventually reach terminal velocity. To the observer, gravity is the more obvious force. Acting on skydivers, their velocity would continue to increase at a rate of 9.8 meters per second squared, or about 32.2 feet per second, each second that they fell. After 10 seconds of free falling, they would have been moving at 98 meters or 322 feet per second if gravity were the only forces acting on them. As they continue to fall, they would continue to get faster and faster. But we know this isn't the case. So, isn't the only force acting on skydivers. Air friction or drag pushes up on the bodies as they fall through the air. Drag is another word for the force of friction between the skydiver and the air. All right, so on this, you don't actually have to write this down. However, this would be something good to know. You might see a question like this again. This isn't a typical vocabulary word that's going to be tested, but you never know when you're going to see that again. So the force of gravity is constant, but the drag increases with the skydiver's speed. As skydivers fall, they eventually reach a point where the size of the drag force equals the size of the force of gravity. The drag continues to push down while gravity continues to pull down. Starting back here with the drag continues to push up while gravity continues to push down. And the two forces counterbalance each other. The skydiver reaches terminal velocity. So when the two forces are equal, so when the force of air friction terminal velocity happens. And just tell you, this is a great question that you might see on a future assignment or test talking about how terminal velocity works. So I would take a moment and summarize how, and what we're talking about here is how it happens in relation to the forces, the force of friction in the air and gravity. So take a moment and summarize that before we start reading the paragraphs. So look at the top one. Because of the terminal velocity of spread eagle divers is very nearly the same, they can perform patterns like the one seen here as they fall. So they're all falling at terminal velocity, so they're all going almost the same speed. All right, the bottom picture. By controlling the amount of the body that is exposed to drag in the air, a skydiver can change the terminal velocity here. A skydiver falls in a spread eagle position since the maximum amount of body is exposed to the air. The air friction is greater and the terminal velocity is smaller when it is pointed straight down. So that's what they're talking about, is the way they're holding their bodies. So if you look at the top picture and the bottom picture, you can see their arms are out and their legs are out. So this is what they're referring to as spread eagle. More of their body is exposed to the air in this. So the air is pushing against their entire body. Whereas if you were going straight down, the only part of your body that would be meeting air resistance would be your head and your shoulders. So that's what it's referring to. All right, so let's check out the paragraph. Controlling terminal velocity. Skydivers can make their terminal velocity faster or slower by changing their body positions as they fall. For skydivers falling with their backs or stomachs parallel to the earth, terminal velocity is about 50 meters per second, or 164 feet per second, after 10 seconds. If skydivers were going headfirst, terminal velocity would be twice as fast, or 100 meters per second, or 328 feet per second. Why the difference? Terminal velocity also depends on the surface area of the diver against which the air is pushing during the fall. The greater the surface area, the greater the drag. The smaller the surface area, the less the drag. Comparison, think of swimmers. They feel much more resistance entering the water with a belly flop than a skydive. Sorry, nosedive. All right, so before we go to the next page, for you to be able to talk about that occur here. And we're referring to in that how surface area and are related. Started on the reading of the paragraph. Again, let's take a moment to look at the photo. So parachutes are designed to take advantage of air friction, allowing skydivers to land safely. So let's just go back to the last page where we talked about surface area. The parachute has a much greater surface area when it opens up. So that enables drag to happen, which slows your descent and thus allows you to land safely. All right, so let's check out the rest of it and look at the questions. Falling at terminal velocity without a parachute is still too fast to land safely. On need a parachute. Parachutes help slow skydivers even more by greatly increasing their surface area. Large parachutes are more powerful than smaller ones. The larger the parachute, the greater the air resistance acting on the diver, and the slower the terminal velocity. The smooth, safe landing increases proportionally. So what it's saying, but the bigger the parachute, the safer the landing, because you're going to slow more. Whereas the smaller the parachute, the faster the landing. All right, discussion questions. Let's take a moment and answer these in your science notebook in the already have set up. If you don't, you need to go look at the science notebook setup and get that corrected and fixed in your notebook. So number one, how is air friction the same or different from sliding friction studied in this lesson? Jumping from a spacecraft near the moon. This article, we're going to be looking at rock climbing. So let's begin. Rock climbing. Two people, one powerful force. So rock climbing is not usually thought of as a team sport. For most climbers, however, it is. The climber has a partner called a belayer. As the climber ascends the slope, the belayer often remains below. The job of the belayer is to keep the climber from falling. The climber or belayer places anchors at the top of the climb or at some convenient other location. The belayer holds one end of the rope. The other end of the rope is threaded through the anchor and then attached to the climber's waist. As the climber ascends the slope, the belayer holds the rope. If the climber should slip and fall, the belayer would hold onto the rope and prevent the climber from falling to the ground below. Coming up from the bottom left of the picture, it's going above her to some anchor point, which is then holding her by slip off of the wall. She would not fall to her more than likely death. All right, next section, going up. Both partners make full use of a powerful force called friction. It's kind of like we've been talking about friction for a second now. So climbers use friction to make their way up the top. While deep rock face, the climbers constantly look for holds or cracks and crevices into which they can wedge their feet or small rocks or ledges where they can grasp or step on. If the rock face is smooth, climbers have to rely on the friction between their hands and feet and the rock face keeping them from falling. Increase the force of friction by wearing shoes with specially designed soles. These soles cover more of the foot than the soles of everyday shoes. This is important because this makes it easier for the climber to get some parts of the sole of the shoe on the rock and create a lot more friction with the rock. So before we go any further, let's take a look at the shoe here. So you're talking about, like, notice this is all sole that they're talking about. So it doesn't matter where your foot is, if you can get rubber on it, it's going to help you keep your. So that's the picture here. The climber shoes are designed to help to grip the rock surface and prevent their feet from slipping. Belaying device. We talked about belaying on the last slide. So the belay device, this literally you run the rope through here, and this hooks through your carriage or your harness. Hang on. Way up a mountain or cliff, belayers keep their eye on their progress. Belayers use one of several methods to increase the friction on the rope to ensure that the climbers will be safe. For example, belayers can wrap the rope around their hips. The their clothing and the ropes, between their clothing and the rope wrapped around them is far greater than the friction between their hands and the ropes. Should the climbers slip, belayers can control the fall better than they would if they were just holding the rope in their hands. More often, belayers thread the rope through a special metal device that increases the friction on the rope and decreases the force exert if the climber falls. Climbers and belayers often, Climbers and belayers aren't usually thinking about friction when they're moving up a mountainside. They're focusing on their goal, reaching the top. Friction helps keep them safer and the climb easier. And unlike those special shoes and mountaineering equipment, it's absolutely free. So let's look at these. Again, these are entered in your notebook. So if you need to, pause the video to add these to your notebook for these. So if there are not, go ahead and add numbers for these, but it's just 1 and 2. All right. So what are some ways rock climbers overcome the force of gravity? Consider that. Some other situations in which gravity is counterbalanced by friction. On the video or use your handouts to go back and find the answers to those. What about here? We didn't highlight a lot, but what you need to make sure you remember is how climbers make use of friction. So, as you're taking notes, maybe find some stuff in this article about how climbers are affected by friction, how it helps them, how it can save them. Lab at this point. Make sure your stuff is set up for submission. Please let me know.